So if you're building global applications on AWS, you've probably stumbled upon two services that sound kind of similar: Global Accelerator and CloudFront. They both promise to speed things up using AWS's massive edge network. But, and this is a big but, they are not the same thing. Not even close. The confusion is totally understandable, especially when you're not just building a website. We're talking gaming, IoT, streaming. That's where the choice gets really critical.
Okay, so here's how we're going to break this all down. First, we'll talk about why global latency is such a beast to begin with. Then we'll properly introduce our two services. The absolute key, the real game changer, is understanding the difference between the application and network layers. After that, we'll see how they actually work, figure out which one is right for your specific job, and then wrap it all up with a super simple decision matrix.
All right, first things first. Why do we even need services like these? Well, it's because the public internet, it's a bit of a chaotic mess. It's like trying to drive across the country on congested back roads during rush hour. If your users are on the other side of the planet, that chaos can absolutely destroy your app's performance and, the user experience right along with it.
Let's make this super concrete. Imagine you're building a real-time multiplayer game. You've got players in Tokyo, Berlin, and Sao Paulo all trying to connect to your servers at the same time. You're probably using TCP for things like logins and leaderboards, but the action, the split-second gameplay, that's all running on UDP.
For that kind of real-time UDP or TCP traffic, things like high latency, the delay, and jitter, which is the variation in that delay, they are absolute killers. I mean, it's the difference between a clean headshot and getting fragged yourself. Throw in some packet loss and unstable connections, and your awesome game becomes a frustrating, unplayable mess.
And this is exactly the problem AWS set out to solve with its edge services. The two main tools we have in our toolbox here are AWS Global Accelerator and Amazon CloudFront. Both of them promise to make your application faster and way more reliable for all those users around the world.
The secret sauce for both is that they leverage the massive private AWS global network. The goal is to get your users' traffic off the wild public internet and onto AWS's clean backbone as fast as possible. But how they do it, and, more importantly, what kind of traffic they're built for, well, that's where they go in completely different directions.
Okay, now I really want you to pay attention to this next part, because it contains the single most important concept for telling these two services apart. Seriously, if you get this one distinction, you'll know which one to pick pretty much every single time.
Sometimes the best explanations come from the community, and this quote from a Reddit discussion it nails it. CloudFront lives at the application layer, or layer 7. It thinks in terms of HTTP requests, web pages, and API calls. Global Accelerator, it's down in the trenches at the network layer, layers 3 and 4. It just thinks about raw TCP and UDP packets. It honestly could not care less if it's a web page or a real-time game server update.
So let's really break that down. CloudFront is a content delivery network, a CDN. Its main job is to cache your web content, your images, your videos, at edge locations, making the distance to the user shorter. Think of it like putting a mini warehouse of your stuff in every city. Global Accelerator is completely different. It's not a cache. It's like a private, congestion-free toll road for your data. It gets your network packets onto the pristine AWS network right away and gives them a clean, fast, optimized path straight to your application.
Okay, so that's the what. Now let's get into the how. Let's pop the hood for a minute and see how this big architectural difference actually plays out in the real world. How do they each give you that speed boost?
Global Accelerator's entire mission, its whole reason for being, is to minimize the time your traffic spends on that chaotic public internet. It uses the massive AWS global network to find the absolute best, most optimal path for your TCP and UDP packets to get to a healthy endpoint, completely bypassing all the internet's usual traffic jams.
And one of its cleverest tricks is this thing called TCP termination at the edge. Now, normally, your computer has to do this three-way handshake all the way across the world with the server. With Global Accelerator, that handshake happens almost instantly with the local AWS edge location right near you. It's like shaking hands with a doorman right at the entrance. Then, a second, super optimized connection is made over the AWS backbone. This shaves critical milliseconds off your connection time before you've even sent a single byte of real data. CloudFront, on the other hand, its game is totally different. It improves performance mainly through caching. If a user in London requests an image, CloudFront can just serve it up directly from a cache in London. It never has to go all the way back to your main server in, say, Virginia. And yeah, it does route dynamic HTTP requests over the AWS network too, but its real superpower is that intelligent caching right at the edge.
All right, so we've got the theory down.
how does this translate to the real world? When do you actually pull one tool out of the toolbox versus the other?
This right here perfectly illustrates one of Global Accelerator's killer features. It gives you two static Anycast IP addresses. Now, Anycast is just a fancy word for saying these IPs act like a single front door to your entire global setup, automatically routing users to the healthiest and closest destination. So as you can see in this diagram, if your main region goes down, boom, traffic is instantly, we're talking under a minute, rerouted to the healthy one. Your users don't have to do a thing. It just works. For high availability, that is a huge deal.
So the choice becomes pretty clear, right? If you're working with anything that's not standard web traffic, like gaming on UDP, IoT devices talking MQTT, or voice over IP, Global Accelerator is your go-to. It's also the perfect choice if your application absolutely needs a stable, static IP address that never changes, or if you need that super fast, predictable regional failover for high availability.
So where does that leave CloudFront? Well, it's still the undisputed champion of the web world. If you're caching static content, speeding up dynamic websites or APIs, or protecting against application layer DDoS attacks, CloudFront is the tool that was built for that job. But, and here's a really cool pro tip, you don't always have to pick just one. You can actually use them together. You can put CloudFront in front of Global Accelerator to get the best of both worlds. Amazing caching for your website and a high-speed toll road for your backend API calls.
Okay, let's put all of this together into one simple final takeaway. If you're going to screenshot one part of this whole thing, this is it. This is your cheat sheet for every time you have to make this decision.
Let's just run through this one last time. Primary layer, application for CloudFront, network for Global Accelerator. That's the big one. Protocol support, HTTP/HTTPS versus TCP/UDP. The use case, web content versus those non-HTTP, low-latency apps like gaming. The key feature, caching versus that optimized network path and static IPs. And finally, pricing. CloudFront is mostly per request and data transfer, while Global Accelerator has a fixed hourly fee plus a premium for that data transfer. You're basically paying for guaranteed premium performance.
So it all just boils down to this one question. Are you trying to shorten the drive by moving your content closer to your users, like CloudFront does? Or do you need to get on a private, congestion-free toll road to get your raw network traffic to its destination as fast and as reliably as possible? The answer for your application, whether it's gaming, IoT, or a website, is hiding right there in that choice.